All right, welcome back to Mr. Read Math, where we're going to take some more mystery in math and make it past tense. And we're going to continue right along with this summer's incoming final exam study guide review and pick up where we left off. I believe we just finished question number 19, so now we're going to do question number 20. So without further ado, here we are. All right, we were just talking about pentagons, and now we're going to take a look at one that maybe isn't quite so normal. All right, now we used to call, or what we would call a pentagon that had all the same measurements, we would call that a regular pentagon. But now here we have the case of a pentagon. The measurements certainly are not all the same, okay? But it still obeys the same rules as pentagons. In this case, we're being asked to find an angle. Not just any angle, we're being asked to find an exterior angle. And it's for an angle we don't know the interior angle for yet. So it kind of hopefully makes a little bit of sense that the first thing I need to do is find this angle, all right? And then once I've done that, I can subtract that from 180 because this whole line is going to measure 180 degrees, right? And I can subtract that angle from 180, and that'll tell me what the question mark is, all right? So what am I going to do? I've got 4 of the angles marked for the pentagon. I need to subtract those from something so I can figure out what that is, but what do I subtract them from? Well, fortunately, we've been working with pentagons already, and from 2 questions prior, we know that all of the interior angles, doesn't matter if it's a regular pentagon or a wonky one, it's still going to total 540, all right? So I know that all of these angles added up, all the interior ones, are going to be 540, and I just need to, one at a time, subtract them from that to figure out what's left over for that one. So I'll pull out the calculator. I'm going to start with 540, and I'm going to subtract one at a time. 104 degrees minus 118 degrees minus 96 degrees minus 115 degrees, and that leaves me with 107. So I know that this angle is 107 degrees. And then to find that exterior angle, I'm just going to subtract that from 180 to finish the line. So 180 minus 107 is 73. All right, so the question mark is 73 degrees. Done. Got it. All right. Easy. Speaking of easy, all right. Question number 21, you are not allowed to miss, or I will haunt you in 11th grade. All right. Question number 21, the sum of the measures of the exterior angles. It doesn't matter if the shape has 3 sides or 3 million sides. If you add up all of the exterior angles, it's always going to total 360, period. Done. End of discussion. All right, a triangle has 3 exterior angles. If it's a regular triangle, each of them is 120 degrees. 120 plus 120 plus 120 is 360. A square has 3 exterior angles that are all 90 degrees. 90 plus 90 plus 90 plus 90, you guessed it, 360. It doesn't matter. It always totals 360. Moving right along. Number 22. All right, when your instructions say the parallelogram, it's saying this shape, regardless of what it looks like to you, this shape is in fact a parallelogram, which means those properties of a parallelogram all apply, such as 2 pairs of parallel sides. Well, these 2 sides are parallel to each other. That's what that little black triangle mark means, okay? And these 2 sides are parallel to each other, so 2 pairs of parallel sides, all right? Another one is that consecutive or adjacent angles are supplementary, meaning they total 180. Means if I go from this angle to this, the total angle, not the split angle, from this angle to this angle, the total is 180 degrees. If I go from this angle to this angle, it's 180 degrees. You know, if I add these 2 together, 180 degrees, right? So, and then the last property that is also kind of interesting is that opposite angles are congruent. All right, so I want to go ahead and let's start answering. I got 3 things to find. I got to find y, got to find x, and I got to find z. Well, z is opposite from 96. These 2 angles are congruent according to parallelograms. So let's just go ahead and write that down. Z is 96 degrees. Sweet. Now what are these? A couple steps I got to do for this one, all right? I don't know. How could we, well, let's do it this way. This entire angle, all right, is going to be supplementary with 96. That means this angle plus 96 degrees is 180 degrees. So if I take 180 and subtract 96, I get 84. Right, so this entire angle here is 84 degrees. Now I've got a piece of that angle right here, that's 31, which means the other piece And this is where some people might make the wrong assumption. They look at that and they might think, well, they kind of look the same to me. So if that's 31, that's 31. No, not with a parallelogram. With some parallelograms, yes, but not just a generic parallelogram. Okay, that comes in a minute. All right, so I can't make that assumption. But this angle plus this complete angle is that's 84, and both of those total 180. So if I subtract 31 from 84, that'll tell me what that other piece is. All right, so take 84 minus 31, and it's 53. Okay, so now, well, what does that tell me, Mr. Reed? I need to find these two down here. Well, it helps just finding it up here, but let me show you how it all goes together, because the other thing we know is that we have a triangle. All right, a triangle has an interior angle sum of 180 degrees. That means 96 plus 31 plus whatever that angle is going to be 180. So let's turn that around. Let's take 180, let's subtract 96, and subtract 31. What do we have left? 53 degrees. Oh, that sounds familiar. So 53 degrees is y. All right, and then do you see how these two link up? And then these two are also going to link up. All right, so 53 x is going to be 31. All right, so let's write that down there. Okay, because these are in fact two congruent triangles. One's just turned around. Okay, so that's that one done. All right, now that was number 22. Let's move on to question number 23. Another one that has the parallelogram written in the instructions. Cool. All right, so all rules for parallelograms exist, and it's wanting us to find this length right here. Okay, from A to M. All right, now another property of parallelograms is that their diagonals bisect each other. Okay, they don't intersect at 90 degrees. That's a different shape. All right, but they do bisect each other, which means that this length is going to be the same as this length because it's chopped in half. It also means this length is going to be the same as this length because they're bisected. All right, well, gee, AM, that's what I'm looking for. It'd be kind of cool if I knew what AO is. Well, look at that. Oh, wow, what do you know? AO is 6. Well, that means AM is going to be 6. All right, that one's done. Cool. Let's move on to 24. The rhombus. All right, so the instructions say the rhombus. That means that shape is a rhombus. A rhombus is a special type of parallelogram where, yes, the intersection between the diagonals is 90-degree angles. All right. It also has another property that says the diagonals bisect their angles, okay? Which means whatever this angle is, that little piece is, it's going to be the same. It's going to be exactly half, all right, when that line cuts through. So those two are going to be the same, right? And that's important because angle 3 is only half of that angle. So that's going to help us solve that. But right away, because it's a parallelogram, opposite angles are the same, which means angle 1, which we're told is 140, is going to be the same as angle 2. So angle 2 is 140. Cool. Now, what's left? Well, again, adjacent angles are going to be supplementary. So if that's 140, then this entire angle is going to add to 140 to give us 180. All right, so let's take 180, subtract the 140 for angle 1, and that tells us that this entire angle is 40 degrees. All right, and because this diagonal bisects that, we know that angle 3 is exactly half of 40 degrees, which would be 20 degrees. There we go. All right. Moving on to question number 25. Now, 25 doesn't tell us conveniently what the shape is, all right, but we do have parallel lines, which means it's a trapezoid. Okay, I can't tell you with any certainty that it's a parallelogram, a rectangle, a square, or anything, but I know it's a quadrilateral with two parallel lines. Okay, and so trapezoids, they have a special rule that if you look at the parallel lines, what I recommended you do is you just kind of cover up half of it. In this half, those are going to be supplementary. They're going to total 180. All right, in this half over here, those are going to total 180. All right, so what you do is you look at this half of it, and I take 180 minus 65. That'll tell me what that angle is. All right, so 180 minus 65, and so that equals angle A is 115 degrees. All right, and then we do the same thing over here. These two are supplementary, right? 109 or 180 minus 109 is 71. Okay, 115 degrees for A, 71 degrees for B. That's how you do it with the trapezoid. Okay, moving down, again, a trapezoid, and now we're dealing with the mid-segment. And what I know is that with the mid-segment, that means for this line segment, the middle, the exact middle, is where that point is. And same thing here, the exact middle is where that point is. And what you notice, as we go from this length, it kind of consistently and gradually gets shorter and shorter. So the amount of shortening between here and the top, halfway up, is going to be half. Well, there's a rule. What you can do, in the way the formula is set up, is you take base 1 and base 2, you add them together. So base 1 plus base 2, and then you divide by 2, and that'll tell you what the mid-segment length is. Of course, I think there's an easier way to do it, but let's see what we've got. Let's go ahead and put the numbers in. DC is 75. Okay, AB is the top one, and that's 27. Okay, so using the formula, I can just say 27 plus 75 divided by 2. I can also look at it, and I can just say from 75 to 27, it shrunk by 48. Okay, and halfway up, it's going to shrink half as much. So from 75 to LM, it's going to shrink 24. So 75 minus 24 that should be 51. Okay, that's kind of how I do it in my head. But if you use the formula, it's going to give you the same answer. All right, so base 1, 27, plus base 2, 75. Let's do 27 plus 75 is 102. Divided by 2 is 51. Same answer that I got. Okay? So however you are more comfortable doing it, if you're more visual, the way I do it may make a little more sense. But if you want to use the formula, just use the formula, and that'll get you the same exact answer. All right, cool. That's question number 26. All right, I think I'm going to pause there with this video. We'll come back in at question number 27. We're about halfway through the study guide, and we'll see you in a minute.